Today we're going to talk about composite solids. Composite solid is just a 3D shape that is composed of two or more shapes. So think about any of the solids that we've talked about previously, like a rectangular prism and a pyramid. Now we're just smashing them together kind of in a way. All right, so here's a couple examples. All right, number one, we have kind of looks like a staircase, right? Where you have the bottom, which is a box, and you have the top, which is a smaller box, otherwise known as rectangular prisms. What I like to do is just separate them into two separate solids. So we have solid one, which is just that small one sitting on top, and then we can see, okay, well, it's B times H. Every prism is going to have this formula depending on what the size of the shape is, or what the size of the base is. In this case, the base is just a rectangle, so we're going to use length times width, and then we multiply it by the height. Okay. After that, we just see, okay, 4 times 2 times 0.5. Well, where is that coming from? So if it's this little guy up here, it's going to be 4, a length of 4. Length of 2, so they're both of these boxes are going to have a width of 2, and because they're just sitting on top of each other, the exact same width. 0.5 is going to be that height. So we multiply that together and we get 4 feet cubed. The reason it's cubed is we have feet times feet times feet. So it's feet cubed. All right, splitting it up into the second box, we have the big box on the bottom. So same thing, we have the base times the height. Now we're using different dimensions because it's a different box. In this case, the length is 6, the width is still 2, and now the height is 1. We're going to multiply them. 6 times 2 times 1 is equal to 12 feet cubed. All right, here we go. So now we're going to find the total. The total is just the sum of the two. Since you're just smashing them together, they're sitting on top of each other, you add them together to find the total volume. So that's going to be 4 plus 12. And 4 plus 12 gives us 16 feet. So the total is 16 feet cubed. All right, pretty straightforward if you know how to find the volume of each individual prism. In this case, they're just rectangular prisms, so you use the same formula, but you got to be careful with what dimensions you're using for each one. All right, now let's find another one that's a little bit more difficult. And the only reason it's more difficult is because now you have two different shapes. So you have a pyramid and we have a rectangular prism or a box. First one is the box, easiest one to find. We're going to break that up. So it's going to be, okay, and then the second one is a pyramid. So let's go ahead and do the box first. So we have the base times the height, where it's the base area, otherwise known as length times width times height, is the volume of a box. Okay, since they're all rectangles, you're just multiplying everything together. All right, after that, we see, okay, well, we have 10 is the length of that rectangular prism. The 4 is the width, and the 3 is the height of that box right there. Multiply them together, and you're going to get 120 feet cubed. So that's the volume of that box. Moving on, if we have the pyramid now, we're using different dimensions and a different formula. So it's still base times height, but it's 1/3 of that, and it's different dimensions because we have a different height. However, the length is still 10. Let's put it here. The length is 10. So this right here is going to give us this 10 is this 10 right here. We have the 4 is the width right here. And now this height, that 4 is going to be that height right there. Notice how kind of the pyramid is just goes edge to edge of the box. So that's why the length and the width are the same. However, the height is different because that height is not the same as the one we used for the box. Okay, let's get rid of that. We multiply that together and we're going to get 10 times 4 times 4 is 160. So we get 160, but we have to take 1/3 of that. So you're just taking 160 divided by 3. It's the same thing as multiplying by 1/3. And we get 53.3 feet cubed. I'm rounding there as well. Okay, so find the total. All we're doing is adding the box plus the pyramid. So the box plus the pyramid is going to be 120 plus, oh, that's not 40. That should be 53.3. Oh my gosh. That should be 53.3. So let me go ahead and change that. There's a little mistake on my part. Must have lost focus when I was doing that. So this should be 53.3. 3. All right. I have a feeling I'm going to have to fix the next one as well. Okay, and then we add those together, and well, yeah, that's not right. So we're supposed to add them together, and since I carried the 40, I added to get 160. Nope, that's not right. So we have 120 plus 53.3 should be 173.3, and I don't have a space to write feet cubed, but you do need to write feet cubed. That's what I get for not using a pen. I'm just using my mouse to write this, so it's going to be pretty hard to read. But 173.3 feet cubed is the total volume of this solid, of this composite solid. Okay. All right, let's move on. Slightly different one. I wouldn't say this one's any harder or easier than the one we just did. If I'm going too fast at any point, feel free to pause and rewind and all that fun stuff. That's the beauty of technology. You can take it at your own pace. All right, we have two solids here. The first one is a cylinder. So you see that cylinder on its side, and you see the cone on top of it, kind of like a party hat, but it's like laying down. So you have a tired cylinder that just partied and is now laying down with its party hat on. Okay, so we have the cylinder is a type of prism, kind of in a way. It doesn't come to a point. It's got two bases, two circular bases, so we're going to call this a prism. And the area of that base right here is given by pi r squared. Okay, so it's given by pi r squared, so that's going to be your area of that base. And so then you multiply that by h. Okay, so let's go ahead and keep going. The radius of it is 3, so we're given that as 3. Look, they're going to share the same radius. It's nice and easy, so they share the same radius. They're both going to have a radius of 3. So we have 3 squared, and then multiply that by the height of the cylinder, which is 7. Multiply, so we have 3 squared is 9. 9 times 7 is 63. Keep the pi with it. I'm not going to multiply yet because that's going to be too much rounding too early on. We round at the very end. So we have 63 pi inches cubed. Save that for later. Next, we have the solid 2, which is going to be the cone, the party hat right here. Okay, so it's very similar, right? It's the base times height, but now we're dividing by 3. And so right here we have pi r squared, where r is the same. It's still 3. So you see this 3 and this 3 come from the same spot since it's just the radius. However, now we have a height of 4 since it's the height of the cone and not the cylinder. So the cone has a height of 4. All right, so we have 3 squared is 9. 9 times 4 is 36. Then we divide 36 by 3 to get 12. Right? I didn't show all that, but that's what I did in my head. So we have 36 divided by 3 is 12. Again, don't multiply by pi yet. That's too much rounding too early on. We'll do it here in a second. So we have 12 pi for the volume of this cone. As always, we're going to add them together since it is a total. You're smashing them together. So we get 63 pi plus 12 pi. And now think about it kind of like terms. They both have a pi. We can add them together. And we get 63 plus 12 is 75 pi. Now we can multiply 75 by pi and we'll have to round. So now we only have to round once. Okay, so we have 235.6, 235.6 inches cubed. All right, and that is basically, actually that's it for this problem. Okay, so the volume of this cylinder who just partied and is laying down with its party hat is 235.6 inches cubed. All right, now we have the next one. This next one's a little bit different. Okay, so we have the volume of this composite solid, which is a box. But imagine now, maybe it's like a piece of wood where you drilled a hole in it. Okay, so that cylinder is not something you're adding onto it, but you're taking away part of the box's volume, like if you drilled a hole out of a piece of wood. Okay, so we're still going to set it up the same way, where we have two solids, a box, and in this case a cylinder. So let's go ahead and find the box. Very easy. We've done those before. You take the length, width, and height. So it's 10 times 14 times 12. All right, 10, 14, 12. That's pretty simple. Just ignore that cylinder for now. This is the original height, the original volume of this box. So multiply them all together, you get 1,680 inches cubed. All right, moving on to the cylinder. Finding the volume of a cylinder is still pretty straightforward. So it's still pi r squared h, okay, where you have the radius is 2, okay, it's given to us as 2, and the height is just the height of this box, right? See, the cylinder goes all the way through this box, so it's still 12, right? So we see that right here, radius of 2, height of 12. We get 2 squared is 4. 4 times 12 is 48. So we get 48 pi. And so right here, I'm actually going to multiply it through. So I get 48 times pi, and I'm going to round it to 151. The reason I multiply it here is because the box is not in terms of pi. So if I just want to make them match up. So if the box was in terms of pi, then yeah, I would keep it in terms of pi here. Just make sure they're the same. So we have 1680 and then 151 for our cylinder. So this one's going to be a little bit different. In this case, we are going to subtract. We are taking away the cylinder from the box. So that just means you are subtracting whatever you got for the cylinder, which was the 151, from whatever you got from the box, which was the 1680. And so that shows right here. So there you go. We're taking it away. It's like drilling away a piece of wood. The total is 1529. Feel free to double check my work, but 1680 minus 151 should be 1529, and that is the total volume of this composite solid. All right, feel free to pause, screenshot, take these notes, and we're going to move on now to some general steps of how to find volumes of really any composite solid. Okay, and I didn't do like an entire exhaustive list of examples because you notice I didn't do anything with spheres. You can do volume of spheres too. If you just say take a half of a sphere, sit it on top of a cylinder, and now you have a composite solid. I didn't do it, but that doesn't mean it's off limits. You might be doing that at some point as well. All right, anyway, step number 1 is just identify each solid, just like what we did. So I'm going to kind of go back. We have solid 1, solid 2, so we identified them. Find the volume of the solid. Just work it step by step, do one at a time. So you're going to do solid 1, find the volume, solid 2, find the volume. Make sure you are using the correct dimensions for each. Finally, find the total volume. If you are combining the solids, that means you're just going to add the individual volumes together. If you're taking away, meaning like if one of the solids creates a hole in the other one, you're going to take that away or subtract it from the bigger solid. Okay, and that's basically it. So these are the list of steps. If you didn't write any of this down, I would at least write this down right here.